In this video, I'm going to talk about Barro's tax moving model and some of its implications, including the condition of tax moving, when that will happen, and also the optimal government deficit. So the first thing I'll need is the government budget constraint, written here. This term is government consumption. This term is government investment. R is the interest rate the government pays on its debt. And pt-1 is the net debt, the government borrowing last term. So the whole thing is the interest payment on the government debt. Okay, so that is the spending side of the constraint, and here is how the government get its revenue from. So T is the government tax revenue, and as is in rich, the revenue from printing more money. R is the revenue, the return the government get from its investment, and D is the government budget deficit. So this equation here outlines the relationship between government budget deficit D and government debt B. To better understand it, we can also see it as dt plus bt minus 1 equals bt, which basically means the debt from the last period plus the deficit, which means more borrowing, becomes the new debt the government owes. And here is a relationship between government investment and the return. So when it invests GI in the last period and the return on the investment is RG, here is the return it gets from the investment this term in this period. Okay, so now we're going to substitute this here and this here. Okay, with that substituted in, let's make some simplifying assumptions. I'm only going to consider a two-period model and assume that the initial investment in the period 0 is 0, and also investment in the second period is also 0, and the government is not going to leave any debt unpaid in the second term, so B2 is 0. And from this equation, we can substitute that in here and get that D1 plus D2 equals minus B0. And with a positive B0, this means D1 plus D2 is going to be negative. Okay, I will write the government budget constraint in period 1 and period 2. Okay, so now for period 1, the first term here will be G1C, second term will be G1I, this term is B0. Okay, the right hand side, this term is T1, this term is S1, this term G0I is 0, so we ignore it, and this is B1. For the second period, this is G2C, this is G2I, but we have assumed that this is 0, and also this term is B1 here, so right hand side T2 and S2 plus G1I here, and also B2 is 0. So we are going to rearrange this, and derive a new intertemporal government budget constraint. Okay, From GBC2, I divide every single term by 1 plus r, and I get this. So I then substitute B1 into the first constraint here, and I get the intertemporal government budget constraint, and I call that 1. Okay, after I've done that, I see that this term G1I here has appeared twice in this equation, so I move the G1I on the left hand side to the right hand side, and I get this equation. So here we have got a result when RG equals R, the last term drops out. So this gives us the golden rule of public finance. If real return RG on public investment equals real interest rate R on public debt, then public investment GI has no effect on the net liability of the government. So debt financing or public investment is fine. So in other words, it's optimal for the government to borrow to invest. Okay, I now move on to deriving the tax moving part. So the government here aims to minimize the deadweight loss from its taxation, tau 1 and tau 2 on income, y1 and y2. So this gives us the fact that taxation in the first period is a fraction tau of income y1, and same thing for the second period. Notice that the deadweight loss here is quadratic in tau 1 and tau 2, so the rate at which tau 1 and tau 2, the deadweight loss increase at an increasing rate as tau 1 and tau 2 increases. So this property comes from the Haberger rule in microeconomics. So I'm going to call, also I substitute tau 1 y1 and tau 2 y2 into t1 and t2 here in this equation. Okay, after this I write out the Lagrangian associated with this problem. It is very long, but the first order conditions are quite easy. So I get these two first order conditions, and then I get the result that tau 1 has this relationship with tau 2. Okay, now I get the equation of net government liabilities. So I define the symbol is the net government liabilities, and I get this equation by rearranging the intertemporal government budget constraint. And then I define sigma as the present value of seniorage. And we get our result of perfect tax smoothing. That happens when rho g is equal to r. Remember, rho g is the discount rate of the government of the that we lost caused by the distortion tax tau 2 in the second period. And when that equals r, we get tau 1 equals tau 2, and that is from the first order condition we just derived. And we can also rearrange, I can substitute sigma into the net government liabilities, and using the fact of perfect tax rate smoothing, I got this optimal tax rate. So So now with the condition for optimal tax rate, let's see a special case here. I further assume that B0 is 0 and the seniorage is 0. So the equation of tau is written in this way, and now I define x tilde as the permanent level of xt. This means if you receive a constant level of x tilde for every single period, then it is as if you are receiving your actual income for the periods. So that is the present value of the permanent level of x tilde the present value of permanent x is the same as the present value of xt, and we define this for both gc and also y, and we got this relationship in here, and this means that now the optimal tax rate is this ratio permanent gc over permanent g.